Okay, so the second way you can get multiple solutions are the solutions due to multiple angles with the same terminal side. These differ by multiples of 2 pi. So integer, it should say integer multiples of 2 pi. Our solutions to some trig function theta of theta equals a will be theta 1 from the previous video, the first way you get multiple angles, theta 1 plus 2 pi k, and theta 2 plus 2 pi k, where k is any integer. So we write that as k in, with this kind of little epsilon looking thing, k in z. It's a blackboard z. If a is in the range of trig. If a is not in the range of the trig function, then there's no solution. Okay, so I wrote that out. And that does happen. So for example, if I had sine theta equals 5, that would have no solution because sine theta oscillates between -1 and 1. So it's never going to be 5, right? So it's very helpful to remember the ranges of these functions. Theta can be an expression of x. That's specifically why I use theta here and not x, is because if I use x, then when it's actually an expression of x, you get confused. So for example, solve sine of 2x plus 1 equals 1/2. 2x plus 1 is theta. 2x plus 1 is what we call the argument of sine. Okay, so the argument of your trig function is the angle. So my solution, I look in the CS plane, and there's two triangles that have sine of 1/2. I'm thinking opposite over hypotenuse. Well, the hypotenuse is always positive, so the opposite must be positive. That's why I know it's in the triangles in one of these two quadrants, quadrant 1 or 2, because that's where the rise is positive, right? Remember, sine positive, S positive. It's another easy way to remember it. So I just drew my two triangles and labeled them. Do this. People skip this. They skip this and then they're completely confused and wonder why. So go ahead and do this. And you'll notice that the second angle, the reference angle for the second angle is actually this theta 1. So to get theta 2, you go all the way up to pi, and then you back off by pi over 6. So subtract out the pi over 6. You get 5 pi over 6. Okay, so those are your two angles that you get from the stuff on the previous video. The source of multiple solutions, number 1. Then we have to add 2 pi k to it because each terminal side, if you add 2 pi k, you have the same terminal side. Okay, so you have two different equations to solve. And I took the first one, I subtracted 1 from both sides. I get 2x equals pi over 6 minus 1 plus 2 pi k right there. And then I divide everything by 2. So I divided the 2x by 2, the pi over 6 by 2, the minus 1 by 2, and the 2 pi k you divide by 2. So you get pi k. And then for the second one, I did the same thing. I just subtracted 1 from both sides of this. I get 2x equals 5 pi over 6 minus 1 plus 2 pi k. I have to divide all the terms by 2 to isolate the x. So I did that. I get x equals 5 pi over 12 minus 1/2 plus pi k. Okay, so you want to make sure that you get this problem down cold. If you can do this one, then the other ones should be easier. Because sine is the more complicated one because of the relationship of the two the two triangles here. They're supplementary.